Hello guys, welcome to another good video. And in this video, we are going to go ahead and configure GRE with IPsec on top of it. So we are going to configure phase one, which is the IC version one phase one, which is the ISACamp, and then we are going to configure the phase two IPsec, which is IPsec, and we're going to configure the transform set and also the IPsec profile. We're not going to be using a crypto map. And if you don't know the difference between the crypto map and the IPsec profile, go ahead and watch my video on how to uh, and on what are the difference between the crypto map and the IPsec profile and why the IPsec profile um, is better than the crypto map. So you should go ahead and watch that video, which is called Crypto Map versus IPsec. Okay, so let's go ahead and start with this configuration, which takes a little bit of time. So first thing that we need to do, I just want to configure a host name over here. And also I have not configured any of the interfaces. So let's go ahead and configure interface gigabit 00, which is this one for router 1. And it's going to have an IP address of 40.1.1/24, no shutdown. Okay, exit out of here. And now what we're going to do is the first thing that we're going to have to do is to um, to configure IKE version 1 phase 1, which is the ISACAM. So let's go ahead and do that. Crypto um, ISACAM policy is the first thing that you configure, and the policy is going to be um, policy 1. And I also want to go ahead and save all my configurations over here so I can just go ahead and drop it on the other router so I don't have to waste a lot of time. So the encryption is going to be 3 des. The authentication is going to be pre-share. So we're going to be using a pre-share key. For hashing, it's going to be MD5, so hash MD5. Diffie Hellman group number is going to be 2, and the lifetime is going to be 80. It's a 86400. There we go. So now we can go ahead and we can just go ahead and copy all this. It should be good because this needs to match on the other side anyways. Um, so for IKE version 1, which is the same as saying ISACamp. ISACamp is IKE version 1, basically. Now it needs to match on both sides. So all of this needs to match. So that's why I'm putting it there. So I can just go ahead and copy and paste it. Okay, good. And after we do that, we need to go ahead and create the crypto ISACamp key, CCNP security. That's how I'm going to call it. And the address needs to be the peer IP address, which is going to be 40.1.1.2. And this is what they're going to use to authenticate. So let's go ahead and copy it and just put it right here. And for the other side, it's going to be 40.1.1.1 because it needs to be the opposite since we are going to be configured from router 1. And the peer is going to be this one over here. Okay, so that is done. Um, so we are done with phase 1. What we now need to configure is the phase 2. So we need to configure the transform set and give it a mode, which is going to be tonal. And we also need to configure the IPsec profile. We're not going to use the crypto map anymore, like I said before. So let's go ahead and do that. You go ahead and do a crypto IPsec transform set. And we're going to call these transform sets GRE tset. And we are going to be using ESP with 3 des for the encryption and ESP ND5 with HMAC for the um, data integrity or the hashing algorithm. And the mode is going to be tonal. There we go. So now let's go ahead and just copy this so we can Go ahead and paste it on the other side because this needs to match on both routers, and the mode also needs to match. There it is. So after we do that, we need to go ahead and configure that IPsec profile, and we need to attach that transform set into that profile. So as you can see right here, we're now going to do the crypto map. So we do crypto IPsec profile, and you need to give it a name. So we're going to go to GRE IPsec profile, just like that. And all you need to do is set the transform set, which we call GRE T set. Boom, there it is. So now let's go ahead and copy this. I did a control C. And let's clear this up. Good. So after that has been configured, the next step is to configure that GRE tunnel, which is a logical or interface that we need to create. So we're going to do interface tunnel, and the tunnel is going to be number 1. And we need to specify the tunnel source, which is gigabit 00, which is a local IP address, which is the local interface that I'm using to connect to router 2 over here. And then after we do that, we need to specify the tunnel destination. And this tunnel destination is replacing that peer that we set on the crypto map. And that destination is going to be 40, that one, that one, that 2, because it's going to router 2, right? Okay, so after we do that, we need to specify that we're going to use the tunnel mode of GRE with IPv4. After that is done, we need to create an IP address for this tunnel, for this logical interface, tunnel 1. This is going to be 40.1.1.1 slash 24. And after we do that, we are going to create, or we're going to attach that profile, which is this one right here. So let's go ahead and copy it, paste it right here, and it's going to be tunnel protection IPsec profile. And there it is. So we are done configuring on router 1. As you can see, ISACamp went from being off to being on. So that is good news for us. So let's go ahead and copy all of this and just paste it over here. And then we just need to go ahead and clear all this out. Interface, tunnel, source, destination. Clear this out as well. IP address, this destination IP address needs to be 40.1.1.1. The IP address of the logical interface is going to be 40.1.1.2. IPsec protection is going to be the same because we are going to give it the same name on router 2. There it is. So this is done. Done. Let's verify our configuration. Crypto as a can policy 1, 3des, the um, destination 40.1.1, 40.1.1, 50.1.1.1, 50.1.1.2, and also let's go ahead and before we configure all of that, what we want to do is go ahead and go into interface gigabit 00, give an IP address of 40.1.1.2, no shutdown. We need to add that subnet mask over here. There we go. So now we can go ahead and just copy all of this and paste it into router 2. But before we do that, let's also give it a host name of R2. Host name R2. There we go. Copy all of that, and let's go ahead into router 2. First, let's go ahead into the configuration mode and paste all of that. And it looks like we got an error, and the error that we got is because we did not remove this right here. Let's go ahead and remove that, copy it. Let's go ahead and actually exit out of here, paste it, and there we go. As you can see, we did not get any errors. So now it should be working. It said that it already exists. Appreciate you for that. That's fine. So now this tunnel should be up and running. And the way that you could verify those is by doing a show crypto ISACamp SA, and this one is for phase one. See, phase one is up and active. As you can see, it's KM idle, but it is active. Let's go ahead and do a show, actually the same show. Instead of ISACamp, we're going to do IPsec SA. And as you can see right here, looks like it is good. No errors. We're using port 500 because we're not using NAT. When we're not using network, when we are using NAT, we are going to be using port 4500. But since we're not using NAT, we're using port 500. And you can also do a show. Let's see what we want to see. Show crypto IPsec SA detail. You can see more details on it. Good. And if you do a show run and you do a section of crypto IPsec, you can see everything right here. It looks good. We can compare that with router 2. And let's verify tunnel. All that is good. We can also do a section crypto ISACamp. Verify the ISACamp configuration, pre-short key, MD5. All of that is good. Let's go ahead and go into the other side. CCMP, group 2, and it looks good. It looks like we have the same. Let's go ahead and do another show crypto ISACamp SA. It looks like it is an idle. Let's see if we are able to ping 40.1.1.2. We are able to do that. Okay, let's go ahead and do some debug commands. Debug crypto. Um, let's do debug crypto IPsec states and debug crypto IPsec and try to ping that again. Looks like it's working. We can do some debug. And as you can see, actually, if we do a show crypto IPsec SA, it looks like it's now being encrypted over here. So we are seeing some debug commands over here. So inbound proposal transformed. It looks like it is being configured now. Okay, let's go ahead and do a ping again. So crypto IPsec still on a. Let's go ahead and do ISACamp SA. Okay, so source and destination. Good. Let's see if we're able to ping 50.1.1.2. So we're not able to ping that tunnel. Let's go ahead and do a show interface tunnel 2. Show interface is tunnel in here? Tunnel 2? Actually, tunnel 1. There we go. Look back, not set. Keep alive, not set. 50.1.1.2, which is good. It looks like it is down. Let's see if we um, config T. I think on the leaf pad, let's go ahead and change this tonal to be tonal number 2 instead of number 1. And let's go ahead and do no interface tonal 1. Okay, so it was off anyways. It went to off. So let's go ahead and change it to number 2. And let's just go ahead and copy this stuff right here. Well, actually, we don't even need to do this. We just need to go ahead and copy this from here, paste it. Now, as you can see right here, the line protocol on interface tunnel 2. So let's see what we get over here. As you can see, it looks like it is working now. Let's do an on all to turn off all the debugging commands. And let's do a show crypto as encapsulated. You can say it was deleted. This one is an idle. And no state. Let's go ahead and do show interface tunnel 1. Let's see what we can learn from here. It's up and up, so it looks like it is good. Let's do a show crypto IPsec SA ping 40.1.1.2. So crypto SA is still not encrypting or decrypting. Let's see over here, 8 bytes. Using this 2. Let's go ahead and ping again and see over here. Are we able to ping 50.1.1.2? We're able to do that. Now let's see if crypto IPsec, there we go. So now whenever we ping the tunnel, as you can see now we are able to, it is encrypting and decrypting, so it is working. So if we do a show crypto IPsec SA, you can see that we have 5 incremented. So now if we do a ping 50.1.1.1, and if we do a show crypto IPsec SA, it went up to 10. And if we do another ping, it's going to go up to 15. There we go. And this one should also be 15. Let's go ahead and do that again. There we go. So it is encrypting and decrypting it. So it looks like it is working the way we wanted it. The local crypto endpoint is 40.1.1. Remote is 40.1.1.2. So it is working the way we want it. And also if we do a show crypto, is it IPsec profile? We can see the profile that we have created. There's also a default always in there that comes with the Cisco router. And here's the one that we created. So it is there and it is working. And you can see that we added that transform set, which is the GRE T set over here. Working good. Let's go ahead and do show crypto IPsec transform set. And here's the transform set that is attached to the profile. So it looks good. Let's go ahead and do it over here. Even though we know it is working, I'm just showing you guys the commands that you could do. IPsec profile. Here it is, the same one, the same name, and the transfer set that we have attached to it. Now let's go ahead and say transfer sets to see that transfer set that we created. And there it is, using it's actually this one. This one is the default one. We're using this one, which has ESP with 3 desks for encryption and ESP MD5 for hashing or data integrity. This one is for data confidentiality. So as you can see right now, everything is working. The data is being encrypted and decrypted. And also if you want to do a let's go ahead and do the debug command now. Debug crypto IP, where's the debug crypto IPsec states. And if you do a ping now, still not showing. What if we do a debug crypto packet or engine packet, and then we print this? You can see right here that the data is being encrypted. So you can see right here, you cannot see what's going on because everything is being encrypted and decrypted. And also, if we do it over here as well, debug crypto engine packet, and we ping from here, you can see over here being encrypted and also on router 2 as well. So this is it for this video. One of the problems that we came across was that when I did a copy and paste, I used the same tonal interface. So I just changed that tonal interface to 2 instead of being 1 for both of them. And I think that did the trick because it was not working and I was not able to ping this interface or this tunnel, and that's why the traffic was not being encrypted. So it is working the way we wanted it. So thank you guys for watching this video on how to configure GRE with IPsec on top of it with IKE version 1. We configure IKE version 1 phase 1, IKE version 1 phase 2, where we configure on the IKE version 1 phase 2, we configure a transform set, and then we configure a profile, which we attach that transform set. Um, and then we created that um, interface, the logical interface, which is the interface tunnel 1, which is the GRE tunnel. We created in the source and the destination, and then we added that profile as well in there. So thank you guys for watching this video. I hope you guys enjoyed, and if you guys enjoyed this video, why don't you just go ahead and subscribe to my channel at subscribe to my channel and then follow me on Twitter at CCNA Daily Tips. And if you don't have a Twitter account, go ahead and create one and then follow me. Thank you guys for watching, and I'll see you in the next one. I love you guys. Bye bye.